How are y'all doing today? Okay. I'm doing all right. Um, I was bringing up the quiz on my tablet here so I can have it in front of me. I do have a question about the test I wanted to ask you and get your opinion of. Um, would you want it to be entirely multiple choice and then just submit your work in an email to so I can give partial credit on any ones that you might miss? Or um, I could go into a little more detail in the questions and ask for specific elements like what is the z value, and then what is the probability and that kind of thing, and just do it more fill in the blank than multiple choice. Do you have any strong opinions on that? The test will be available starting this afternoon whenever I get it ready. I have the questions ready. I'm just trying to figure out how I want to do the answers. Um, and then you'll have through, like, I think it's next Wednesday is what I'll do. So do you favor more just straight multiple choice or fill in the blank? Okay. Doesn't matter. Fine. Multiple choice, multiple choice. Either. I mean, yeah, that's true. It would be easier to give partial credit on the multiple choice format. Okay. Half and half? Hmm. Yeah, I could see that. Hmm. Yeah, I could take elements of both and put those together. That might be a good idea. Like have you give specific values, like give the z-score, for instance, and fill in the blank there, and then have you select the area from like a drop-down menu. I don't know if I could do that all in the same problem though. That's the only issue. Um, or could just do some multiple choice and others fill in the blank for different elements. Like the first four problems, very easily done as multiple choice, I think, because they're all pretty straightforward. Um, first 3 problems at least, I could make multiple choice. Maybe the first 5 multiple choice. But then when we get to like the proportion problem and then the confidence interval problems, I might go fill in the blank there for specific elements. Yeah, I could do something like that. That might be good, and you'll still be able to submit all your work, and I can go through and give partial credit based on that. And that's for all 8 problems, not just the multiple choice. So, yeah, I'll put that together after class today. I'll try to do something like that. I think the first 5. Even with the sample size, the central limit theorem problems where you have to divide by the square root of n, it's still a pretty straightforward process. It's just getting the number from the calculator. So you can definitely do multiple choice there. But like on the proportion problem, there's definitely some more details I need you to give me, on that. There's multiple parts, for instance. So that would work a lot better as a fill-in-the-blank problem, for instance. And same with the confidence interval. I would like to have a little more info there. So it will be due Wednesday night of next week. So we'll actually have a little bit of extra time because of the holiday. Test 3, not the final. Test 3. Alright, now, did everyone get enrolled, or were you asked to join a Canvas course for the final exams? So apparently we're having signups for the final exam now, but they didn't tell me where it was. And I thought there was a course you were all supposed to be enrolled in. Let me look at my email real quick. I'll double check on this. I'm sorry. I'll make sure to make an announcement probably later today about that. That way everyone can get signed up for a final exam. You'll have the choice of doing in person or online, so don't worry about that. But I will look into that and make sure it's squared away. Anyway, let's look at this review, at least during today's class, for test 3. Alright. we should be able to use a graphing calculator since we put it in the course syllabus. I don't know what your friend is talking about unless it's her specific teacher that has that requirement. Mm-hmm. If a student indicate that for this is, I mean, did you all fill out the survey that I sent the link for? Um, Gosh, I know a lot of you filled out the survey because I saw the document that had the summary. Um, if you indicate on the survey that you wanted to take the final online, you'll be invited to a Canvas course. I do have links though, and I'll send those out in an announcement later. Um, for you know whether you want to sign up in person or online, there's two different links, and you can pick a time and go from there. Okay, but I'll mention that in the announcement later today. All right. General Electric manufactures a decorative, crystal clear 60-watt light bulb that it advertises will last 1,500 hours. Suppose the lifetimes of the light bulbs are normally distributed with a mean of 1,550 hours and a standard deviation of 57. So this information is provided to us. We know the mean is 1,550 and the standard deviation is 57. And so 1 says, what is the probability that a light bulb will last less than 1,500 hours? Okay. We may have done the similar problem to this when we went over the sections. So I don't remember if this was specific example was used or one similar, but we'll do it again for the review anyway. So 1,500 is our x, and again the z-score here is x minus mu divided by sigma. So we'll convert it to a z-score, graph it on we'll graph the bell curve distribution, indicate where z is, and shade the appropriate side, and then find the value from there. So 1,500 minus 1,550 and divided by 57. So negative 50 over 57. And so we'll calculate that. And for that we get a value of negative 0.88 if we round to 2 decimal places. Okay. Now negative 0.88 is a little bit to the left of 0. And we want the probability that the light bulb lasts less than 1500 hours, which means we'll shade to the left. Okay. And so our lower boundary is -10. Our upper boundary is -0.88. From there, in our calculator, the second data over to distribution, down to normal CDF, 0 and 1 for the mean and standard deviation once we standardize it, and then -10 for the lower bound, and -0.88 for the upper bound. Go down to calculate. We get 0.1894. Okay. And so that's the probability that a randomly selected light bulb will last less than 1500 hours. Now problem 2 uses the same information. Mu is 1550. And sigma is 57. Now we want the probability that the light bulb will last between 1500 and 1650 hours. Okay. Now each of these is a data value x. Okay, whatever we're given in this probability statement, this is our x, at least in this type problem. So for each of these x's, we'll have to calculate a different z-score. So for x equals 1500, we already calculated the z-score for 1500. That was -0.88. So we can just reuse that z-score here. Now x equals 1650, we will have to calculate this z-score. So it'll be 1650 minus the mean, 1550, over the standard deviation, 57. And so we get 100 divided by 57. So it'll give us 1.75. Okay, so we have each of our z-scores, and we know we want to find the probability between these two z-scores. So we have -0.88. And we have 1.75. Since it's between, we know we'll shade the area between. And that's our lower and our upper bound right there. So we can put those into the calculator. The lower bound is -0.88. Upper bound is 1.75. Calculate. So we get 0.7705. Okay. And as we said, we'll go ahead and make this these two multiple choice. So you'll just Select the correct option on the list. Okay. Any questions so far? Okay. Problem 3. The number of chocolate chips in an 18-ounce bag of Chips Ahoy chocolate chip cookies is normally distributed with a population mean of 1,262 chips and a population standard deviation of 118 chips, according to a 1999 study. Determine the 90th percentile for the number of chocolate chips in an 18-ounce bag. Now, a problem like this, there's a lot of extra numbers there that we don't need. Because we talked about the year, we talked about the size of the bag being 18 ounces. We don't need either one of those numbers. What we need is these three numbers in particular. We need the mean, the standard deviation, and the percentile requested. Now, this one is an inverse normal problem. That's the function that we use in the calculator instead of our normal CDF. Now, we go to second in data. Let's see, inverse normals are third option there. Okay. Now our area, this is our percentile. So 90th percentile means area is 0.90. So basically we just take our percentile and translate that into a decimal. That's our area. Our mean we said was 1262. And our standard deviation 118. We go in there and we can just calculate from there. And it gives us a value of 1,413. And it gives us a decimal point too, but we'll go ahead and call it 1,413 chocolate chips. We don't really worry about fractional values here. We just want the whole number of chocolate chips that are present. On the calculator, so again we do second data, go over to distributions, down to inverse normal. Usually, for the most part, we're using normal CDF, option 2. This time we use inverse normal, this problem. Now again, we said our area is 0.90 for the 90th percentile, so we entered 0.9. And we entered our mean and standard deviation as they're given in the question. And then we just press enter, go to calc, and there's our answer. Okay. Alright, number 4. Suppose that a local doctor studied the pregnancies of a random sample of 36 of her patients. So that's our sample size, 36. From the past year, the population mean for the length of pregnancies is known to be 266 days. And the standard deviation is known to be 16 days. So question 4 asks, what is the probability that the average length of pregnancy for the sample is less than 270 days? Okay. Now in this case, our value given in the probability statement is x bar, because we're not just finding a data value, we're probability of a certain data value being an outcome. We're looking at the mean for the sample, which is x bar. So what is the probability that the sample mean is less than 270? Well, we'll use x bar equals 270 in this case. Now our z-score formula is a little bit different here. Because we also incorporate the sample size n into the calculation. So we use z equals square root of n times x bar minus mu in parentheses, and then the whole thing's divided by sigma. So n is 36, so we have square root 36, x bar is 270, mu is 266, and on the bottom, sigma is 16. Now the square root of 36 is exactly 6. 270 minus 266 is 4. Then we have 16 on the bottom. So 6 times 4 divided by 16. We end up with 1.5 as our z-score. So, 0's in the middle, 1.5 is further to the right. And we want the probability that the average length of pregnancy is less than 270. So less than here means to the left. So we'll shade to the left of our number, 1.5. Because it keeps going to the left and doesn't stop, that means our lower bound is negative 10. And our upper bound, the right edge of our shaded area, is at 1.5. So we again go into our calculator, second data, distributions, normal CDF. Now, you'll notice that in problem 3 we changed the mean and standard deviation. At this point, let's change it back to 0 and 1 right here. Otherwise, we'll end up with the wrong answer. It's easy to overlook that because we're used to just kind of clicking past that with the enter button, but we want to make sure those are 0 and 1 when we're using the z-score. For problem 3, we weren't using the z-score, we were just using the raw data. And we said our boundaries were negative 10 and then 1.5. Calculate, and that is 0.9332. Well, we'll round to 4 decimal places every time we find an area. So make sure you do that. Yeah. Although the answers are not going to be close enough together on a multiple choice test where you might mistake one for another. As long as you did everything right, you should be close or right out the answer here. Okay. Now problem 5 is a lot like problem 4. The only difference is we want the probability that the average length of pregnancy for the sample is greater than 260 days. So the initial information is all the same. N is 36, mu is 266, and sigma is 16. It's still the same as in problem 4. This time, though, we want the probability that the length of pregnancy is greater than 260 days. So now 260 will be our x bar. So z is equal to square root of n times x bar minus mu divided by sigma. Square root of 36, x bar is 260 minus 266, and that's over 16 on the bottom. Now square root of 36 we know is 6. 260 minus 266 is negative 6, and then it's over 16. So we would take 6 times negative 6 and then divide by 16. And so that ends up being negative 2.25. Right. Now negative 2.25 is pretty far to the left. And then we want to shade everything to the right of that because it says greater than 260 days. So greater than would be everything to the right. So our lower bound will actually be negative 2.25, and our upper, because it keeps going to the right, will be 10. Now, on the 83s, we go second and vars, and that gets us to our distribution. Arrow down to normal CDF, and we enter, we actually do our lower first, negative 2.25, comma, our upper 10, comma 0, comma 1. The 0 and 1 is for, whoa, things got a little out of control. The 0 and 1 is the mean and a standard deviation of the standard normal distribution. So we always have to enter that. And we press enter. It gives us a result of 0.9878. Now we should get the same result on either calculator. I just wanted to demonstrate on this one once again the difference in entering those numbers for those of you that have an 83. Are there any questions on these two? So those first 5 are more or less similar, but those will all be multiple choice as we decided. But again, I will allow you to submit your work if you want me to look at it for partial credit. And you'll certainly know how well you did once you submit the test. Whether so if you get 100 on the exam, then you don't need to submit your work because you've already got everything right. But if you see that you didn't get some right, then you definitely want to submit your work just for me to look over and see if I can give you some points back. Okay. All right. Let's move on to number 6 on the review. It is believed that 30% of Americans believe that places can be haunted. Suppose that 205 college students are surveyed as to whether they believe places can be haunted, and 65 reported with yes. So we're given a proportion of 30%, or 0.30, that believe places can be haunted. We surveyed 205 college students. And 65 responded with yes. So that means, so remember that N is the sample size. We use that quite a bit. But in this case, the number of responses to one answer, to the question, that's always what we call X in this case, which we have not used as much, only in the context of these proportion problems. So that's what we get from the introductory statement. Now we want to find the following. A, show that the distribution is approximately normally distributed. And to do that, we have to show that n times p times 1 minus p is greater than or equal to 10. Now on the test, what I'll probably have you do is calculate n times p times 1 minus p and fill in the blank with your answer. And it should be greater than or equal to 10. N is 205, p is 0.30. So we have 205, 0.30 for p, and 1 minus 0.30 for 1 minus p. If we subtract those, though, that's 0.70. And so we just have to multiply all that together. 205 times 0.30 times 0.70. So for that, we get a value of 43.05 multiplying all together. And it is bigger than 10, so we can confirm that it is approximately normally distributed. Okay. That's all we need to do on part A. Now for part B, it says calculate the value of p hat. Now for p hat, we know the formula. This is our sample proportion. The formula is x divided by n. So we got 65 divided by 205. That was given to us in the problem up here. So we just take 65 and divide by 205. So we get, let's call it 0.317. 3 decimal places is pretty good here. We don't really want to go too much further, but 0.317 is good. What I'll do on the test is I'll specify how many places to round to, which will likely be 3 places. Possibly 4, but likely 3. Okay, now in part C, we want to find the probability that p hat is greater than the value in part B. So find the probability that p hat is greater than 0.317 by first calculating the standard deviation and then the z-score. So our standard deviation, sigma p, is the square root of p times 1 minus p over n. And what I'll do is I'll put this as a separate blank to fill in on this problem. It's calculating the sigma. Let's see, so that would be square root of 0.3. Now 1 minus p we already found was 0.70, or 0.7. And then divide by n, which is still 205. So we take square root of 0.3 times 0.7 divided by 205, as we see here. Press enter, and that's going to be 0.0320. Now this one we might take out to 4 decimal places. In this particular case, 3 is perfectly fine because it has a 0 as 4th place, but in general we might want to go to 4 here. So, but I'll again be sure to specify in the exam just so you can fill in the right value. Okay. Now z is equal to p hat minus p over sigma p. Now p hat we said was 0.317, p 0.30, and sigma p 0.0320. So we calculate that, we get 0.017 over 0.0320. And for a z-score, we always want to round to 2 decimal places, so we'll call that 0.53. Okay, that's our z-score. Now, remember when I read the question, we want the probability that p hat is greater than 0.317. So we calculated the z-score for 0.317. The reason I used that was that's the number we got right here. Now, in the question, it says find the probability that p hat is greater than the value in part B, which is where we calculated the value of p hat. So we'll just have to fill in that value ourselves there. But greater than is the key phrase here, because that means we'll shade to the right of our z-score that we found. Right. Zero's in the middle, so 0.053 is a little bit to the right, or 0.53, sorry. We want the probability that's greater than that, so we shade to the right of that. So our lower bound for this area is 0.53, and our upper bound is 10. So now we can finally put that into our calculator and find the probability. 0.53 for lower, 10 for the upper. And so we calculate, we get 0.2981. So about a 30% chance that if we asked 205 people what they believe here, that we would get a probability that is at least 0.317 or higher. Okay. Any questions there? Now, remember I said to skip 7 because we didn't cover that section, so we'll go to 8. Total plasma volume is important in determining the required plasma component in blood replacement therapy for a person undergoing surgery. Plasma volume is influenced by several health and physical activity, influenced by the overall health and physical activity of the individual. Suppose that a random sample of 45 firefighters are tested. N equals 45. And they have a plasma volume sample mean of 37.5 milliliters per kilogram. We'll just say X bar is 37.5. Don't worry too much about units unless you're actually applying it. And that is a 7, I'm sorry. And sigma, the population standard deviation, is 7.5. And we want to create a 90% confidence interval. Now, so 90% confidence interval, that consists of two parts. We have X bar minus the error term and X bar plus the error term. E, we said, is our error, margin of error. Now, the issue here and how we find the margin of error is based on whether we have a population standard deviation or a sample standard deviation. Now, this will be made clear in the paragraph. So, if you look here, let me rotate this. Excellent. So, if you look at the question here, okay, that's not what I wanted to do. I just want to download that and open it. There we go. Sorry about that. Just to save time. So there's our question. And are we dealing with the population standard deviation or the sample standard deviation here? Sample? Population? It's one of those two. Notice right here, it's going to, when it states the standard deviation, I'm going to specifically state whether it's population or sample in front of that. Okay, so look where it gives us the standard deviation, 7.5. I'll make sure to include either population or sample there. In general, if we're not told, we should anticipate it's a sample, but this one specifically tells us it's a population. Okay. Oh, okay. That's why I called it sigma versus S. A sigma for population, where S would be the sample standard deviation. Okay, so our margin of error, if we know that the value of sigma, and again, this is in your formula sheet, which I'll make sure to include afterward, is our margin of error if sigma is known. Is E equals Z alpha over 2 times sigma divided by square root of n. And specifically, if we have a 90% confidence, then we can use Z alpha over 2 as 1.645, which is what we're trying to find here, 90% confidence. If we were using 95 or 99% confidence, then we have the other values provided there also. So in this case, sigma is known because that's the population standard deviation, and that's what's been given to us. We'll use this first one. So we use this formula for the margin of error, and this would be our Z alpha over 2 for 90% confidence. So let me write that down now. So E is Z alpha over 2 times sigma over the square root of n, and we know that Z alpha over 2 for 90% confidence is 1.645. Okay. Now, from there, we just plug in our values to this formula for E. So E is equal to 1.645 times sigma, which we found was 7.5, and divided by the square root of n, which is 45. Now, on our calculator, we can just do that all in one go. So we can do 1.645 here times 7.5, and then divided by the square root of 45 equals, and we get a value of 1.84. Okay, it's 1.839, but we can round it to 1.84. Okay. The reason we'd want to round to 1.84 to two places specifically is because our original data is to one decimal place already, so we'll just go one place further here. Alright, and so our confidence interval we said is x bar minus e comma x bar plus e. Now x bar we know is 37.5 minus e, our margin of error, 1.84, comma, and then our x bar plus e, so just the same two numbers added instead of subtracted. So we'll go ahead and carry out that subtraction and addition. we get 35.66 and 39.34. So we are 90% confident that the mean value of what we're talking about, plasma volume. Let me get back to the question. Sorry. Total plasma volume for firefighters, at least, this is the population that we're looking at, is between 35.66 and 39.34 milliliters per kilogram. Main thing I'm looking for, though, is the numbers here. So each of those, so you'll have a blank to fill in for each of the elements here, and then these two especially. All right. Any questions on that? Not in this case, because I would like for you to do, but I may split it off into a separate problem because I'm not going to be able to put it in the same problem with these blanks. So what I'll do is I'll probably do a separate question worth less points just for writing the sentence. So just to give you an idea of what we can write, we are 90% confident. So we want to make sure we mention the level of confidence, which is 90% in this case, that the mean total plasma volume is between 35.66 and 39.34. And we could specifically say for firemen, since that's the group that we're studying here. Firefighters, sorry. Must be gender neutral. There we go. So yeah, I'll put that as a separate question to allow you to write that sentence, but it won't be worth nearly as much as the original because it's just a small part of the overall. I'll figure out the grading. Okay, and then number 9, all the way to the last one. In a random sample of 30 felons convicted of aggravated assault, the sample mean of length of sentencing was found to be 54 months, with a sample standard deviation, so notice it says sample standard deviation, of 8 months. Create a 95% confidence interval for the mean length of sentencing for an aggravated assault conviction. Okay, so this is the data that we're provided. Now again, if we look at the formula sheet I gave you, in this case sigma is unknown since they gave us the sample standard deviation instead. So E is equal to T alpha over 2 times S divided by root N, where T alpha over 2 is based on degrees of freedom, which is N minus 1, and the level of confidence. And I've got a table on the next page for that. Is that a little bit off the screen? No, that's good. Okay. Now the confidence interval will be found the same way, it's just we have to figure out the margin of error, which will be a little bit different here than it was in the last one. Okay. So our margin of error E is T alpha over 2 times S divided by square root of N. Now, we said that T alpha over 2, we have a 95% confidence, and degrees of freedom is N minus 1, and since N is 30, take away 1, you have 29 degrees of freedom. Okay, so we have 95% confidence, 29 degrees of freedom. So on this next page, I have this t-value distribution. Now notice that 95% confidence is right here in the middle. And so we just have to find, on the left-hand side, let me arrange that so 95 is on the right of the screen. We just have to go down to where we get to 29. So we find 29 right here. Oops, let me go up a little bit further. We find 29 right here, we go across, and we get 2.045. That's the value we'll use for T alpha over 2. So again, make sure you're okay reading that table, as that is vitally important in answering this last question. There is a way to do this on the calculators, but it's so... It reduces the problem just to entering a few numbers and clicking a button, and I wanted to see a little bit more work on this. It doesn't have a z-score per se, so it's actually it's almost mindless as far as how easy it is on the calculator. That's why I didn't want to teach it using the calculator. But anyway, so we get 2.045. So we plug in our values. S, you said it was 8. N is 30. So even though we use 29 for our degrees of freedom, remember we used the original value for N here, 30. So we calculate that. 2.045 times 8, and then divide by square root 30. So we get 2.986. Let's see. How would we round that? Now our data here is whole numbers, so we're going to round to the nearest tenth. Now, let's see. So to the nearest tenth, 2.98. 8 rounds to 9 up 1, so it'd actually be 3.0. Okay. So we get e equals 3.0, that's our margin of error. And so our confidence interval, x bar minus e, comma, x bar plus e, we have x bar is 54 up here. So 54 minus 3, 54 plus 3, that gives us from 51 to 57. So again, we want to describe what this tells us in a short sentence. So we are 95% confident this time that the mean length of aggravated assault convictions is between 51 and 57 months. Not convictions. Sentencing? Is that the word I used before? Let me look at the paragraph. Mean length of sentencing. Mean length of sentencing for aggravated assault is between 51 and 57 months. Okay. And so that would be our sentence that we would use to summarize it. We always like to mention the level of confidence, the two numbers and what they actually reference, which is months in this case, and reference what the mean is describing here, which is the average length of aggravated assault conviction or sentencing. Are there any questions? Okay. So, I will, after we're done here, I'll get those ready, and I'll send out the announcement for the test, and I'll send out the announcement about the final exam and choosing a time. I'll probably do that first because it's a little bit more pressing as far as time. But once you receive that announcement, make sure you respond to it and fill out when you would like to take the final. Anyway, so like I said, I'll get the test ready, and it'll be like we described, so don't worry about that. Yeah, I guess that's all we have today. We don't have class on Wednesday, and so I hope you enjoy Thanksgiving. Hope you enjoy the couple of days off from school, at least. If hopefully you get some time off from work too, so you can relax. But enjoy it. Take care, and we don't have class next Monday either because that's when I've kind of scheduled the test for. So. So our next class will be Wednesday of next week. Alright? You all have a good rest of the day, and I'll talk to you later. Bye.